Asteroids come hurtling out of space, attracted by the greater size of the planet. And on the face of the Earth today, we can see the scars of recent collisions. This crater in Arizona is well known. It's the Barringer meteorite crater and was gouged from the surface only 50,000 years ago. The impact crater is huge, 1.2 kilometers across, just under a mile, and it was thought that the size of the meteor must have been the same. So perhaps buried in the ground was a fortune in iron and nickel. In the early 1900s, the Standard Iron Company was formed by Daniel Barringer to dig out the perceived wealth.
When my grandfather came up this ridge and looked at it, he imagined that the object that made this hole was at least as big as the bottom diameter of the crater, which is, again, more than half a kilometer. He thought this would be millions and millions of tons of nickel iron, and it would be commercially immensely valuable, that he could make millions of dollars here.
The mining venture lasted 27 years, and in today's money cost around $10 million. But nothing of any value was found. But while the mining venture gained nothing except a useless shaft,
Ready? There it goes.
there was to be a winner after all. It was science. In 1928, a paper was published which concluded that the mass of the meteor was far smaller than the size of the crater. Further mining was called off, and shortly after, Daniel Barringer died of a heart attack.
I think I could have easily made the same mistake because it's such a large hole, and it's intuitively, it seems like it would have had to be a huge rock that would have made it.
In fact, the meteorite which caused this crater was no larger than the perimeter fence around the mine shaft. Science learned it was the force that was as critical as the size of the object. But about 4 billion years ago, the Earth was hit by a massive space intruder, 10,000 times larger and 1 trillion times heavier than the rock which grazed the Earth in Arizona. At Stanford University in the United States, Dr. Kevin Zanley of NASA and Dr. Norman Sleep from the university are studying the impacts of meteorites on Earth. But first, they must look at the moon.
But you'd like to look at it pretty early, so you get nice shadows. It's also pretty nice to start with.
On the Earth, the evidence of the very earliest asteroid strikes have been weathered away by erosion or lost with the tectonic movements of the Earth's crust.
Globe. Let's see if we can orient it the same way. Whoa, where is everything?
But the moon has been stable since its creation over 4 billion years ago, so craters are there from that long distant past. By looking at these craters, they hope to estimate the number of times the early Earth might have been hit. It is far larger, its gravitational attraction far stronger, and they estimate that our planet was hit 25 times more often.
Nobody is steering the asteroids that are going to hit, and the Earth, being bigger, just happens to get hit more often.
So what we do is we count the big craters on the moon, and then we scale up to the much larger size of the Earth, and we find that the Earth was hit by asteroids as large as 500 kilometers across, at the same time that the moon was being hit by asteroids that are 100 or 200 kilometers across.
This is an impression of the relative sizes. The largest is 500 kilometers. That's over 300 miles across. Earth may have been hit as many as 6 times by an asteroid this size.
You have a 500-kilometer object moving at 20 kilometers a second, stopping in 20 seconds, delivering all of its energy in doing so. and you produce an enormous explosion. The amount of energy that is released in this event is more than enough to evaporate the world's